In our final discussion of the medium run, we focus on the relationship between inflation, growth, and unemployment. The corresponding chapter in Blanchard is Chapter 9, or depending on your edition, it may actually be part of Chapter 8. Now, there are two primary motivations for discussing these three variables. One is to develop a sense of what impact money growth, as it is common in fiat money systems, has on the economy in the long run. It's this question of, if we keep printing money every year, what are the long-term effects on economic activity and prices? The second and perhaps more important one in this context is to provide a brief introduction to the concept of dynamics, that is thinking how the economy changes over time. Dynamics are a staple of macroeconomics because adjustment times matter when we think, for instance, about the duration of a recession or the lagged impact of a fiscal policy measure. Much modern-day dynamic models rely on higher-level calculus, so we won't cover it here, but at least I'll go through a simple variation that explains the concepts to you that you're already familiar with, especially aggregate supply, aggregate demand, in terms of rates of change rather than in terms of levels, which is a more realistic way of approaching the issue, or at least in the way that a modern-day economist would do it. The basic aggregate supply, aggregate demand model discusses the relationship between output and prices in levels. However, we know that in practice, GDP and its long-term potential path grows over time. Similarly, we're used to ongoing inflation. That's just something that happens every year. Hence, we want to be able to express aggregate supply, aggregate demand in rates of changes as a dynamic version instead of just doing it in terms of levels. Now, one of the components we need to do so, we have already developed last time, and that is the modified or the accelerationist Phillips curve. That put in relation unemployment and changes in the inflation rate, and it came out of the aggregate supply model. To finish a complete model, we need to add additional components, specifically two. The first relates real GDP to unemployment and is known as Okun's law. This completes the dynamic AS relationship, that is the relationship between growth in GDP and, by changes in unemployment, inflation. The second is a dynamic version of aggregate demand AD, and for simplicity I will focus on money growth as its main determinant. Quick review. Assuming adaptive expectations, as we have shown last time, the modified Phillips curve states that the change in inflation, left-hand side here, from one period to the next depends on the unemployment gap, right-hand side here. If current unemployment is larger than the natural rate of unemployment, we have cyclical unemployment and inflation decelerates. Meanwhile, if current unemployment is smaller than the natural rate of unemployment, we have labor market tightness and inflation will accelerate. The coefficient alpha, finally, indicates the strength of this adjustment over time. Okun's law, meanwhile, is a more realistic assumption of something we intuitively have already shown, namely that more production tends to lower unemployment. Growth tends to translate into tighter labor markets. Previously, we had assumed that one worker represents one unit of output, but this is obviously a model simplification. We could make our model more complicated to match reality, but in practice, we sometimes keep things simpler and rely on a relationship that is empirically observed and that was named after economist Arthur Melvin Okun, who first observed it. Namely, historically, the change in the unemployment rate, left-hand side here, from one period to the next, is negative whenever the economy is growing at a certain rate. In the United States, that was the case historically when the economy grew more than 3%, at least in the second half of the 20th century. In years where the economy grew less than 3%, the unemployment rate would increase. What do the 3% represent? This is what economists often refer to as potential growth or trend growth. It reflects, broadly speaking, increases in productive capacity in the economy over time. We will return to this question more after the next exam. For now, just know that there is something like trend growth over longer periods of time. The economy tends to grow at a certain rate from one year to the next. Sometimes we're growing a little bit faster than that. Those tend to be years during which unemployment tends to decline. Sometimes we grow a little bit slower than that, and those are the years during which unemployment tends to increase. Now, empirically, if I show you this relationship, this is for the second half of the 20th century, so it excludes the last 10 years for reasons I will explain. On the x-axis, we have output growth of real GDP per capita, and on the y-axis, we have changes in the unemployment rate. Now, it is fairly evident that whenever output growth was fast, the unemployment rate would fall, or at least it would grow slower. And in years where output growth was small or negative, the unemployment rate would increase. And this is really, in a nutshell, is what Okun's law illustrates. Now, let me make some empirical comments here. For 1% increase of real GDP growth over potential growth, unemployment in the United States historically declined by less than 1%. There are two reasons for this. For one, firms hoard labor during downturns. What this means is that as production initially declines, firms may not immediately lay off workers during a recession. Why is that? Economic data is lagging and imperfect, so firms may simply be hesitant to let workers go when they are not clear that demand is falling consistently and that workers could easily be replaced. They might simply be holding on. In this sense, the current recession will be instructive. But most economic data isn't showing the size of this COVID-19 related downturn yet. We know for sure this time that we are in a recession. That, in combination with support that came from the fiscal stimulus, may have allowed firms to lay off workers quicker in this current downturn than is usually the case. And for that matter, the downturn really isn't showing in the data much yet if you're following me now. The most current available macroeconomic data that we really have are labor market variables. Specifically, employment is the one that comes out the earliest. It's usually published on the first Friday in the first week of the month. For the month of March, employment in the United States fell by about 300,000 workers. That doesn't seem that large if you think that previously it was growing by about 150 to 250,000 any given month. But the reason why the number came in relatively small for March is that it's lagging pretty heavily. The survey that establishes employment figures is done in the second week of the month. By the middle of March, a lot of places weren't in lockdown yet. More currently, we got information that came from unemployment insurance claim, and that data shot up dramatically. Here we moved something in the vicinity of 6 million. For the previous peak, the previous high for that in the 80s was close to 700,000. And that certainly suggests that going into the next month, going into April, we'll see much more dramatic job losses. That is something that we don't have in the macro data yet. And in a normal recession, we wouldn't even know that we are in recession yet. In this case, we know it because we know what's causing it. That affects the relationship that is Okun's law in practice, and it's one of the reasons why it has changed over time as well. Second thought, and this should hopefully be obvious, a 1% increase in employment is not equivalent to a 1% decrease in unemployment, since the unemployment rate is a ratio which further depends on labor force participation. This is something you should have been exposed to before, and if this is not obvious to you right away, maybe go back to your notes and review how the unemployment rate is defined and see if you can figure this out. Finally, much like the Phillips curve, Okun's law, while intuitively, is quantitatively not stable across countries and time. In the US, for instance, there is suggestive evidence that potential growth over the past 10 years has fallen. Population growth is slower, productivity growth has been lower after 2008, and that suggests that this critical number after which Okun's law grips has fallen from about 3%, perhaps closer to 2%. I'm going to table this discussion. It's not really something that I want to go through here. Just be aware that this too is a relationship that has changed over time. To keep it general, we then postulate no particular values for what potential growth should be equal to. We don't really have this 0.4 parameter in there. Instead, we use a general expression that links the change in unemployment to what is known as the output gap, and the coefficient negative 0.4 we simply replace with beta. Intuitively, changes in unemployment correspond to the direction of the output gap. If the output gap is positive, unemployment will fall. If it is negative, unemployment will rise. And be aware that when I'm talking about the output gap here, we're talking about this in terms of growth rates. That's what separates this from aggregate supply, aggregate demand, as we had handled it previously. If the economy is growing faster than potential, unemployment rate will fall. If the economy is growing slower than potential, the unemployment rate